In the United States, this is problem number 2 of the review. In the United States, the probability of having twins, usually about 1 in 90 birth, rises to about 1 in 10 for women who have been taking the fertility drug Clomid. A group of 15 women became pregnant while undergoing fertility treatments with the drug Clomid. What's the probability that none have twins? Well, first off, they set this up where it's pretty tricky. All right. So we're talking about the ones who take Clomid. All right. And they say the probability of becoming pregnant with twins if you're taking a drug Clomid is 1 in 10. So 1 in 10, let's just do this real quickly. 1 divided by 10 just gives me 0.1. So the probability of twins when you're taking Clomid is 0.10. So we need that value. Now we have a group of 15. Because we have a specific number, a specific size group or a specific number of trials, this is a binomial. And we could have 0, 1, 2, 3, ... all the way to 15. But in this case, they want none. Well, that's a singular value. So this means this is a binomial PDF because it's a singular value. Our trials are 15. We have 15 trials. Our probability is 0.10, and our X value is 0. So trials, probability X. And like I said, because it's a singular value, it's a PDF. So second vars, binomial PDF, trials was 15, probability 0.1, X value happens to be 0. And so the probability that none are twins is 0.2058. Once again, please take everything out to 4 decimal places. Exactly 1 will have twins. Well, again, we have a specific number of trials, so this is a binomial. And if we make our number line 0, 1, 2, 3, ... all the way to 15, I'm only circling one number. So this makes it a binomial PDF as well. So trials are 15, probability is 0.1, and our X value happens to be 1. So this is trials, this is probability, there's our X. Keep grabbing the wrong calculator. Second vars, binomial PDF, 15, probability is 1, just change my X value to a 1. And the probability that there's at least, or the probability that there is exactly 1 is 0.3431. All right, at least 3. Well, we know we have a specific number of trials, so this makes it still a binomial. And we have 0, 1, 2, 3, 4, ... all the way to 15. And it says at least 3 will have twins. That means I'm looking for these values, 3, 4, 5, all the way up to 15. I have the phrase at least, so it's a no, it's going to be a 1 minus the binom multiple values. So this makes it a CDF. And anytime it's in at least, it's going to be a CDF. Our trials are still 15. Our probability is still 0.10. And I subtract out the highest value I don't want, which is in this case a 2. I don't subtract out 3 because I want 3. So don't take away what I want because I wanted at least 3. So don't take that away. Just take away what I don't want. So my trials is 15. My probability is 0.1 and my X value is 2. Please don't forget the 1 minus because it's a least problem. So 1 minus second vars, binomial, CDF, trials is 15, probability is 0.1, X value is 3. Or excuse me, X value is 2 because we're subtracting out the 2 because that's the highest value we did not want. All right, and I get 0.1840. equals 0.1840. How many twins should be expected? Well, we know we're working with a binomial because we have a specific number of trials. But they're asking for the expected, so we need the expected value formula for the binomial, which is the expected value equals NP, which in this case means we had 15 times 0.10. So 15 times 0.1 means on average we'd expect to have 1.5 set of twins. And what that means, if we did this over and over and over again, millions of times, and when we had groups of 15, on average, the average for those 15 groups would be 1.5 would have twins. All right, that'll be the end of this video. The next video will be over problems 3, 4, and 5.